It's not ideal. A priority heap would be better, but I think we can do a quick little quick sort on a list. It could be min and max. You mean like it would get the minimum in the list? Ah. Oh. Is that a linear search though? It has to be a linear search. So that would make this take too long time. Actually, is the quick sort even gonna help? Because we'd need to sort again on each insertion. Okay, we'll hold off on that. Quick sort is easy to do. Yeah, I've written a min-max heap. But that was like 20 years ago in university. I haven't done it since. I'd need to brush up on the exact conditions. At any rate, it's not something I'm gonna figure out at 1:30 in the morning. So we'll just use that for now. We'll just use the min and max. Okay, so that gets us our nodes. Then we need to add those nodes to our fringe. It's add. Wait. Actually, you can probably just do get pause, and this would be from all the corridors of the current node. For direction in node corridors. Okay. I want a utility function to get position in direction. So we'll take a direction. I'm just going to do a quick if-else tree here. Am I include plus equals in this language? Don't steal focus from me just because there's an error. I can't fix the error if you do. Please, game. Okay, so the position in direction is equal to get, actually, I'm just gonna make a temporary here. This is get node P. Not on a school night. Focus steps is animation, especially when you're halfway through and entering password. Yeah. So if I accidentally enter my luggage password, promise not to snitch, alright? Snitches get stitches and all of that, right? Okay, so this is the initial state of the fringe. So we have added all of the next nodes to explore. How does min on a dictionary work? Ooh. Can I even have integer keys? Is that gonna mess stuff up? One. Ah. Okay. So I guess we change this to be something like that. The F cost. Maybe that is fast enough depending on how the fringe is implemented. If that's a binary tree, then that's fast enough. Okay, so then let's use proper names here. Pause, pause, and then cost is the let's see. The cost is the current node's cost plus 1, because we have taken one step, plus the heuristic function. Ooh, we need a target position. I think measure gets us a tuple, right? So we should be able to do target and position. So we use that as the index into the fringe. Now we need to actually... Oh, that's not going to work because there's going to be multiple nodes with the same cost estimate. So that's not actually going to work. Unless it's a list and min does something smart. I don't think it does something smart. But it's at least going to work. And then if it's too slow, we can implement a heap or something. That's not f past, that's f cost. Well, that's not how we do that anymore. So we also need to not add anything to the fringe if it's already, we've already been to that node. Yeah. So if was not in visited, then we add, just add the node itself to the fringe. Is it this? Yeah. We'll just add the whole node. But this is just a list of node. So this is then a set. Jeez, I haven't done this in like 20 years either. We're not going to plant, we're not going to do those. I just want to see what the fringe and visited set looks like after the first initial setup. You can't assign a tuple element because tuples are immutable. Very well then. I guess we're doing it the hard way. I mean, it is less lines of code, so I guess it is technically cleaner. Yeah, you're right, game. You're right. That's not how that's spelled. Quick print. It's funny that it's called quick print because the text remains longer. Need output again. Okay. Visit has never... Oh, visited. Yeah, we do need to add the thing to the visited list. Set, add. Also, the starting node needs to be in the visited set by default. Actually, hold on. So visited, add node. And fringe and node. This is where we start. And then for Actually, while. I don't remember the condition. We're just gonna have while true for now, and we'll fix that later. Is it while there is anything left in the fringe? Yeah, I think that's actually true. While length fringe is that a value is to true, right? In this language. Okay, so we don't need to do the thing. We can just write it like that. Okay, so while there is something on the fringe, we will... How are we gonna get the minimum? Oh, that's not gonna work, is it? Yeah, I cannot get the minimum there because I cannot give a key extraction method. Yeah. Have a large starting value there. Okay. This is gonna break the performance, but for right now, I just need a way to proceed. We'll make a function next node to explore. This is going to just loop through all of the nodes. If the estimated cost is less than the lowest cost, then the lowest cost is the estimated cost, and the best node so far is n. Okay. That's subject to optimization. Honestly, it's probably way too slow. But we shall see. Also, I'm gonna call this root. Just to make this clear and so that we can use a node inside of the loop. So now, for each path we can take from the node, actually we need to update the corridors of the node. And here we could do an optimization because we know that we can go back in the direction we came from. So get direction. Yeah, this doesn't need to be here because we're going to do it here. So on the first path through, node is going to be the root. We're going to update the corridors. And for each direction we can take, from here we will create a new node. It's not a new one, but we're going to find the one from our data structure. And new node corridors. We're going to add the opposite of the direction that the corridor was from. So we need a map for opposite directions. Why am I not in bed? Why are you not in bed? Yeah, that does the thing. Why I'm not in bed is because I really want to get this to work. Okay, so that means we can get there from the path we just came. Okay. We need to actually hold on. This we do in here. This is our current node's cost. New node, the actual cost is that. And the node's estimated cost is that. Do you have any other fields we need to set? No, not right now. So we add that to the fringe of nodes to explore. We add it to the visited list. And then we do that for all the directions, and then we take the next node to explore. However, we only add it to the fringe if the estimated cost is less than the current worst. How does this work again? No, wait, I don't think we need to do that. We just need a termination condition. If node position is equal to target, then done. What do? For now, we return. Yeah, we need to build a path. And then we need to return that and follow the path with the drone. However, we do need to map. Do we? Oh, okay. Yeah, I see where I'm getting confused here. So we don't know the map layout at the start. We could do a left hand on wall thing and explore and map the entire maze. And then do the A star. And that would work. I was trying in my infinite wisdom to kind of map and solve simultaneously. But that adds unnecessary complexity. You are right in a really wrong way. Maybe? Yeah, let's start with follow with hand on wall and map, basically. So, yes, do map. So, we need to know our current direction so that we know which is our left side. And let's just pick any direction, north. Okay. So, if we're heading north, then as long as there is a wall on our left, we can keep moving north. As soon as the wall